Precella. Today we're going to look at operations on functions, difference quotients, and composition of functions. And I'm going to just go ahead and start with problem one. Well, let's switch over to my paper. Okay. By operations, I'm talking about the real number operations that can be extended to that concept of functions: addition, subtraction, multiplication, and division. Those are the operations on real numbers, and they can be performed on functions as well. Operations. By that I mean addition, subtraction, multiplication, and division. Addition and subtraction of functions, it's just plain old algebraic addition and subtraction. There's not any real new algebra here as far as the operations on functions go for addition, subtraction, multiplication, and division. It's just a matter of notation. And to illustrate that, let's look at problem number 1. They give us two functions. They give us the function f of x is equal to 3x plus 4. And g of x is the function 2x minus 7. And they ask us to find, notice that f plus g inside the parentheses with the x outside of it. That's saying add the two functions together. They want us to find, first of all, f plus g in terms of x. Okay, let's switch over to my paper. F plus g in terms of x. That's just saying, here's what I'm thinking. That's saying take f of x. You already know what f of x is. They gave it to you, 3x plus 4. And they want you to add g of x. So, just f of x, 3x plus 4, plus g of x is 2x minus 7. And notice how I'm going to write this, that f of x plus 4, just to make the point that all came from one specific function. I'm closing it in parentheses. The 3x plus 4 is together. That came together from f of x. Likewise, 2x minus 7. Those terms came together for g of x. Algebraic, addition, subtraction, multiplication, and division of functions is just algebraic addition, subtraction, multiplication, and division. If I'd come in here at the beginning of the semester and said, let's add these terms together, it's just combining like terms. We know what to do there. Those parentheses I wrote are unnecessary. I just put them there to show that they came together from the function f of x. We didn't need them. I could just drop them. 3x plus 4. The second set, that 2x minus 7, it's another unnecessary set of parentheses. There's a plus there, so that'd be like distributing through a positive 1. That wouldn't change anything. So it's another unnecessary set. We'll just drop the parentheses and write plus 2x minus 7. And we know how to combine these. Addition of functions is just algebraic addition. Looks to me like we're combining like terms. 3x plus 2x, that's a 5x. Now combine the things without an x. 4 minus 7 gives me a minus 3. It's really just a matter of notation. We took what we had for f of x, we added it to g of x. Now in a moment we're going to subtract. There'll be an additional step with the subtraction. Who can see ahead and predict what we're going to have to do when we have a minus there in front of those parentheses? We're going to have to distribute, okay. But for f of x plus g of x, it's just 5x minus 3. Now, oops. 5x minus 3. Okay, and now we have f minus g. F minus g in terms of x. Well, we know what f of x is. It's 3x plus 4. Now I'm going to enclose it in parentheses just to make the point that those two terms came together from the function f of x. And now we have a minus. And g of x, notice how I'm enclosing it in parentheses with the plus. With the plus, those parentheses were all unnecessary. But when we're subtracting, they're not all unnecessary. The first set is unnecessary. We can just drop it and make it a 3x plus 4. But the next one, we have a minus in front, so that positive 2x and minus 7, what are they going to become? Okay, a negative 2x and a plus 7. And once again, this is just combining like terms. Addition and subtraction of functions is plain old algebraic addition and subtraction. The only thing that's really new is that notation we're using right there. Combining like terms, 3x minus 2x. And then we have a 4 plus 7. So x plus 11 is our final answer. This is one of those problems I just love, where it just keeps going and going. It's not difficult, it just seems to drag on, though. We're about to do the third part of 8. What does this mean? FG. If you don't see a sign, plus, minus, times, or divided by, if you don't see an operation, what do you assume it is? Multiplication. Okay. So, that's saying take f of x, and we know what f of x is. F of x is 3x plus 4. Now I'm going to group it in parentheses just to indicate that 3x plus 4, those terms came together from f of x. Times, we want to multiply by g of x. Well, we know g of x is 2x minus 7. You took f of x times g of x. If I'd come in here today at the beginning of class and said, okay, how do we perform this multiplication? This is something we've known all semester long. You FOIL it out. Multiplication of functions is just algebraic multiplication. The only difference is that notation they're using. So we're FOILing it out. First, 6x times 2x, I'll get 3x times 2x gives me a 6x squared. Outer, 3x times a negative 7 is a negative 21x. Inner, plus 8x. 4 times a negative 7 gives me, okay, so we have, combining our like terms, we have a 6x squared, negative 21 plus 8, is that a negative 13? Don't forget the x, and a minus 28. It's just plain old algebraic multiplication. The only thing that's new there is the notation, the way they're writing. They're given the algebraic expressions names, and then showing the operation on those names. So I've seen students in the past, after time has passed and they're doing this maybe a week or two from now, they forget what was done here, and once they get to this answer, they all of a sudden distribute an x also. No.
Have you ever had students do that?
I
Or
don't
did you
think
realize
so.
what they were doing?
Maybe I didn't realize what they were doing.
I had a student once show me what they'd done. I was like, oh my gosh, no. Don't start this. Don't get a 5x squared minus 3x.
It's terrible for me to say this, but I can see. I can see where they would
Once
think
they
that.
showed me that, I was like, oh gosh, I've got to
All
mention
this
that.
is saying is that add the functions and your answer will be in terms of x. That's all that's saying.
It's not saying add them and then distribute an x. You made it harder than it is.
I mean, I could see that. I could see how someone would think that. Okay, go ahead. You didn't write an answer. 6x squared minus 13x minus 28.
Oops.
And finally, look at this. They're denoting division by means of a fraction.
Division's always the hardest.
Generally, don't you think most people would think that division is the hardest operation?
So get ready for this doozy.
This says, take f of x, which is 3x plus 4, and divide it by g of x, 2x minus 7. Now, we need to ask ourselves, can we factor and cancel? These things are linear. Can we factor any of them? Either of them? There's nothing we can do. There's f divided by g. It's just a fraction.
About it being the hardest stuff.
I use a red pen there. Yeah, Tony was joking about that.
It's just f over g. That's it. Don't then start distributing an x. Fraction.
3x plus 4 on top, and a 2x minus 7 on bottom.
So why would we just leave it like that?
If it were something that could be factored and canceled, we would. But there's nothing. 3x plus 4, that's a linear expression. All you could do is take out a common factor. There's no common factor. Likewise there, it's linear, no common factor. What else can we do to it? There's nothing else we can do. If we can factor and cancel, then great. But here we can't factor and cancel.
Now, 2 assignments back. Why don't we
Notice the
review
instructions. They say give the domain of each. Okay. Remember domains of functions. I made the remark. No fractions, no square roots, unless you're told otherwise. What do you assume the domain is?
Yeah.
All real numbers. As long as there's no fractions, no square roots, unless you're told otherwise, and that would be in an application environment. If you're working with revenue functions or cost functions, would it make sense for you to have a negative number? Okay, so you can't just look at the final answer, but f plus g, f minus g, and f times g all have the same domain. Okay? You have to look throughout the work.
And that's a line where you're going to write the answer, not a fraction.
Yeah, that's where I'm going to write the answer. F plus g, f minus g, f times g. Don't just look at the final answers. Look throughout the work, because you could have something like a square root that you square somewhere along the way. Well, if it's a square root, you can't have negative numbers underneath the square root, but the square root could cancel out or something in the final answer. So look through and make sure. No fractions, no square roots, no fractions, no square roots. These are all graphs of diagonal lines. We said the slope of a diagonal line, of any diagonal line, is all real numbers. We said the range of any slanted line is all real numbers as well. But there's no places throughout any of the work there where you could pick up a denominator of 0 or the square root of a negative, because there are no fractions or negatives, or square roots appearing in f plus g, f minus g, f times g. So the domain, all real numbers.
Written with that interval notation. I remember mentioning the other day how you have to type that so much. Here goes 3 times of typing.
Copy and paste it
Yeah.
after the first one.
Negative infinity,
I
comma.
had a online student that's been doing really well email me. Couldn't find the negative infinity. They'd already gone through cut points and everything, and so it never. But for some reason they forgot that there wasn't a negative infinity when they were typing in domains. They were looking for the negative infinity and couldn't find it. You've got to type the negative from the keyboard. Okay. Now f divided by g.
Is that going to be all real numbers? No. Remember we said if there's a fraction, you can't have a 0 in the bottom.
So we look here. There's no work to look through at least. 2x minus 7 can't equal 0. So that means 2x can't equal 7. So x cannot equal 7 halves. X could equal anything other than 7 halves. X could equal 50 million. It just can't equal 7 halves. And if you were going to write this out, we'd say the domain is all real numbers, except except 7 halves.
But of course, we're not going to write it in words. We're going to write it in interval notation.
So if you're unsure how to do that, think of a number line. There's 7 halves. We're not going to shade 7 halves. We're not using 7 halves. But we can use any number to the left is 7 halves. Any number to the right is 7 halves. So how do we say that? It's going to be 2 intervals. Am I going to have any brackets in my interval notation? No, it's only parentheses. So parenthesis, negative infinity to 7 halves, parenthesis, that's saying all the numbers to the left is 7 halves, or all the numbers to the right is 7 halves. And that's how they're going to make you type it in.
You sort of lose the picture of what you're saying. You're saying all numbers except 7 halves.
Could I plug 50 million in here for x? Yes, I could. Could I plug pi in it? 3.1415, blah, blah, blah. Yeah, I can. Only number I can't plug in is 7 halves.
What about 3.5?
Could I plug 3.5 in?
No, because that's the same
That's
thing
the
as
same thing as
7
7 halves. You're right.
Okay.
So,
Oops. There I got parentheses, negative infinity, comma, 7 over 2. Don't do that. If you do, it's going to count it wrong. The parentheses can't be in the bottom of that fraction. So I'll say right arrow, parentheses, parentheses. What do you think of the way they always list this key symbol here that you'll never use?
not in this class.
Not in this class. But then again, when I drive to work, there's streets I've never driven down. I've lived here over 30 years, but there's streets I've never driven down. They're still there. I just got to know, don't drive down those streets. Just say, you got to know, don't click this button.
I just love your real life applications that you pull out. Oh,
But
goodness.
sometimes students have asked me, why do they have those things when we don't use it? Well, there's streets in real, there's a lot of stuff in real life. There's a lot of classrooms in this building that you'll probably never walk into, but they're still there to confuse you. Okay?
Yeah, like the person looking for 204 earlier.
Now, this is the operations part of the assignment.
Do y'all agree there's no new algebra there? It's just for the operations. Switch over to my paper. We'd already discussed how to find domains. We'd already said the denominator of a fraction can't be 0. We knew how to combine like terms and FOIL. So there's really no new algebra here in this, okay, for operations. A specific example of function notation that's important is the difference quotient. That's an important component of the definition of derivative from a calculus class. All we have to do is simplify difference quotients. We don't have to do anything with them other than just simplify them. Okay?
Difference means what? Add, subtract, multiply, or divide. Subtract.
Okay.
Quotient means what? Add, subtract, multiply, or divide.
Divide. Okay.
Well,
so here's the difference quotient.
I was just going to show it.
F of x plus h minus f of x. There's the difference part of it, all divided by h.
And this is a bizarre looking fraction that in future math classes, it'll be assumed that you can calculate this and then you use it to measure the rate of change.
Instantaneous rate of change.
Okay, like how fast is that profit function increasing? How fast is that cost thing decreasing? Stuff like that.
I was reading about Tesla and their new truck that's coming out. So maybe we could say, how fast is the fall of profit decreasing?
Yeah. Have y'all seen
cool.
that picture of the new Tesla pickup truck that's coming out? Wow.
Wow.
It doesn't even, if someone had asked me 20 years ago, I would have been, is this a wow.
Moon buggy or
It
something.
must be something. We must all be flying around and stuff, But no, it's just an electric pickup. Huh.
I wonder what the range is.
You see, we're going to get a 3-step process for finding this thing called the difference quotient.
The first thing we're going to do is simplify f of x plus h. That's function notation. That's going to say go to the function and wherever you see a variable, replace it with x plus h. Then the second part we'll do is we'll subtract off the original function. And then the last thing we'll do, the last part, will be whatever we've got from this, we're going to divide through by h. It's not that bad.
The first part is the part that requires the most work.
Yes.
Okay.
Here's the function. F of x is equal to x squared plus 6. And when they ask you to simplify the difference quotient, even on the, show them number 3.
Number 3. Here it doesn't give you step
1, 2, 3, but we're still going to go through the 3 steps. Even if they don't ask you to use those 3 steps, that's what we're going to do. The other thing is that on the test, if they're asking you to find the difference quotient, I'm not going to assure you there will be problems where they ask you to find the difference quotient. They will tell you what it is. They'll remind you.
Say, do I have to memorize f of x plus h
minus f of x over h? No, because within the instructions, they'll tell you what the difference quotient is.
You just got to know those 3 steps. First, find f of x plus h.
So that's part A. We're going to find f of x plus h.
Okay. Now,
switching over to my paper.
Well, this was something from 2 assignments ago.
Function notation that says go to your function f, and wherever you see a variable, you're going to replace it with what's in the parentheses, x plus h. So we come over here, we're going to replace that 1x with what's in the parentheses. You say, well, there's already an x there. Yeah, I know, but that's what you replace an x with, the blue x plus h. And don't say x squared plus h squared. This is two terms. How do we square a binomial? I remember that popping up on the second homework assignment when we were working with complex numbers. Something like 3 plus 2i quantity squared. If you have a sum or difference being squared, what are you going to have to do?
Give you a hint. It starts with the F. 4-letter algebra word that starts with F.
Foil it out. Write it twice. X plus h times x plus h. I always think of myself as looking on the bright side of things. At least there's not any that have cubes on them. If there were cubes, we'd have to write it twice. Foil the first two out. Combine like terms. Then take the next one. Distribute through the x, distribute through the h, combine like terms. So at the very least, there's not any cubes. That would be certainly messier. But here we're just foiling it out. So first, x times x is x squared. Outer, x times h. I'm going to write the letters in alphabetical order. So x times h, I'll write that as an hx. That'll make it easier to spot like terms. If you have a term with two different letters, write the letters in alphabetical order. X times h and h times x are the same thing, but you'll see why I wrote it as hx in a moment. What's the inner product going to be? Another hx. You see, that's the thing. If you'd have written xh here, you might not notice that you had like terms sitting there side by side. And last, h times h is h squared. Now we spot these like terms. 1hx plus 1hx, what's that going to give me? 1hx plus 1hx gives me how many hx's? 2 hx's plus h squared. This is just my little scratch work. That's just my little scratch work there. I'm foiling out the x plus h quantity squared. So I can write that down. In place of x plus h squared, I know that that equals x squared plus 2hx plus h squared. And what else do I have stuck on there? Plus 6. That's right. And notice there are no like terms, nothing to combine there. Here's the answer for f of x plus h. And that's the longest part of the problem.
Yeah, the rest of it's going to fall out real quick. So let me type in these. X
squared
down there,
plus 2hx plus h squared. Get out of that exponent before you type on the plus 6. Any questions there?
That's the first part. Find f of x plus h.
Now, they want us to take what we just found and subtract off the original terms. If you understand what they're asking for here, you can get this answer without showing any steps. This is saying, take the part A, what you just found, and take away f of x. That's the original thing they gave us. So you take what we just found. I'll say part A. That's part
Isn't
A.
that how y'all first learned subtraction in elementary school? Take away.
That little minus is acting like a takeaway. And f of x, that's the original function. So we have this stuff here. We're going to take away what's up here. We'll have an x squared, take away x squared. So the x squared term has disappeared. What else is going to disappear? The 6. 6, take away 6. So we just got rid of x squared and 6. What are we left with then? 2hx plus h squared. There's part A. Part B. A moment ago I mentioned if that had been an x cubed, how messy this would have gotten here. Regardless, what you'll want to remember is in part B, the terms that remain will all have the letters H.
Sometimes students have asked me, well, wait a minute. When it says take away f of x, what if there's not a 6? Or take away what if you don't have a 6 to mark out? You've messed up.
The only thing that should be remaining, once you find f of x plus h minus f of x, are the terms that have the letter h. Anything without a h, like the x squared and the 6, they're going to subtract out, if you're doing this correctly.
Should you go ahead and read just under here, write this, and make a big mark, marking out the x squared and the 6? Or not?
What do you mean?
I guess, no, I just need what you did here, marking out, write it right there. Copy x squared
plus 2hx plus h squared plus 6. I'm subtracting the x squared plus 6. This is what we're trying to get away from doing. I have to show this. X squared minus x squared. It's subtracted out. 6 minus 6, leaving us nothing more than just a 2hx plus h squared. Did you type that answer in?
I don't think I did I? 2hx plus h squared. 2hx plus h squared.
Okay, part C. Part C.
At this point, y'all have already found the numerator. That was the answer to part B.
All we have to deal with now is the dividing by h. We just found f of x plus h minus f of x. That's the answer in part B. 2hx plus h squared. And we're dividing it by h. If you have a sum or difference being divided by a monomial, the quickest and easiest way to simplify is just split up. We're going to split it up so it's 2hx all over h plus h squared over h. I remember doing that with complex numbers when you had a complex number all divided by a real number. We'd split up and cancel individually. To give us, you can cancel the h here. That leaves us a 2x plus, what's this going to leave us? You cancel an h above and below, you still have an h remaining. For 2x plus h.
So you find the f of x plus h.
That's usually the longest part of the problem. Then you take away what's in the original, and then you divide the terms by h, the monomial divisor h.
2x plus h, is that what it is?
Mm-hmm. And even if they just skip to part C and say, find the difference quotient, I still break it into these 3 steps.
And by you saying I do that, that's your way of saying you should.
You should also.
Okay.
Any questions? Now, number 3, they're not going to say use those 3 steps. They just want the final answer. They just want this, what we have right here. We're still going to break it into the 3 steps. Let's look at number 3. They give us the function. Oh, this is a messier function. F of x is equal to 4x squared plus 9x plus 9.
Why not use color code? F of x plus h blue minus f of x red.
Maybe I will. So I think I'll do it like this instead. We're going to first of all find f of x plus h. This is going to be a little messier because in the previous one there was only one x, wasn't there? In f of x, just that x squared right there. But here there are two x terms. Both x terms have to be replaced with what we have in the parentheses. 4, replace the x with x plus h. Replace. So we're going to replace that x with x plus h. Replace this x with x plus h. And now we're going to have to remove those parentheses. As I told you, there aren't any where there's x cubed. If there were cubed, it'd get messier.
You'd have reason to complain.
Yeah, you'd have reason to complain. With the square, you don't have reason to complain. We know what we have to do there. What are we going to do to that x plus h squared? Write it twice and FOIL it out. There it is. There it is, what we just found. It's not going to change. It's not going to change. It's x squared plus 2hx plus h squared. Look what I'm going to do. We still have that 4 there in front. We still have that 4. So I'm going to replace that x plus h squared with what we found earlier, x squared plus 2hx plus h squared. I just replaced the x plus h squared with what we got on problem 2, x squared plus 2hx plus h squared. And we still have that plus 9 times x plus h.
If you want to go ahead and distribute the plus 9 right now, you could. I think you're going to wait and distribute
all at once. But you could have distributed it right there. The 4 has to be distributed to give me a 4x squared plus here 8hx plus here 4h squared, and then distribute the 9 to give me 9x plus 9h plus, we still have that 9 stuck on there. Notice there are no like terms. Once you find f of x plus h, there are no like terms to combine. I have a desire to circle that, but we're not typing that in.
And that's a good thing, that they're not asking you to break up each part, because otherwise you've got to type all of this stuff in, which sort of slows it down.
Now, we want f of x plus h, what we just found, minus f of x. We're going to take what we just found and take away the original terms. Let's do this without showing work. Which terms are going to drop off here? I'll get us started. 4x squared minus 4x squared. That's gone. What else is gone? 9x minus 9x. That's gone. And the plus 9. 9 minus 9. Remember I said the only terms that are remaining have to contain what letter? H. What happened to that thing over there? So we have an 8hx plus a 4h squared and a plus 9h. I'm going to. So now we've found f of x plus h minus f of x. Now, all over h. The easy way to do it, just put each term over h. And cancel the fractions individually. Remember I said every term had to have an h, so every term's going to have the fraction canceling out. The h cancels, leaving us an 8x plus, what's the second fraction going to reduce to? 4h. Cancel 1h above and below, so all you have is a 4h. What's the third fraction going to reduce to? Okay, the h cancels, leaving us just that plus 9. Any questions there? Once again, the f of x plus h, that's the longest part. And then you take away the original terms, the terms from the original function, then you divide each term through by h. If this were a calculus environment, we'd then start asking ourselves, what happens to this thing here, the value of this, as the h value gets closer and closer to 0? But we don't have to worry about that. All we need to do is simplify difference quotients.
We have a 3-step process for finding difference quotients in this class. In Calculus 1, there's a 4-step
step when you
process.
having to ask yourself what happens as h goes to 0. But we don't have to worry about that. 8x plus 4h plus 9. You better type it in.
8x plus, what did you say?
4h
plus 9. Oh, okay, good.
And remember, there were 3 topics we said in here. And Tony said they were disjoint. Not really. Operations, difference quotient, composition of functions is a 5th operation, one that doesn't apply to real numbers. The first operations we saw were real number operations: addition, subtraction, multiplication, and division. Composition of functions, that's a new operation that's unique only to functions.
New? When was it invented?
I didn't say new, I said unique.
No, you said new. I heard you use the word new.
Oh, you're right, I did. Okay.
Still.
I remember, well, I better not say this, not when I'm being recorded anyway, because I know what you're thinking of about the new. Okay. Composition of functions.
Oh.
And I think I'll let Tony take over now. He does this little thing with these arrows that I never really got the hang of it, okay?
That's just later on.
And so, still, I'll let you. Okay, you want to? I'll continue on. Let's assume.
Oh, wait, are you show the screen?
But don't you think I need to define this new operation?
Okay.
I know we do. Okay, so let's assume we have 2 functions, f and g. Assume f and g are functions.
I think that would have assumed that. It just would.
We need a symbol to represent these compositions, this new operation. If there's no symbol, then it's assumed just to be multiplication. So we have to have a symbol. And if you think about it, all the good symbols, the little T for addition, the little dash for minus, all the good symbols were already taken. But I think the person that invented this operation did a pretty good job with the symbol. F composed with the g of x. Notice the notation we're using. It looks like a little O. F composed with g of x is defined to equal f evaluated at g of x. It's function notation. They use an O for the word of. F of g of x.
That's an O, not a dot. A dot would be times. This is not times.
And likewise, g composed with f of x. The first function that's written, that's the function on the outside. And the second function, that's the inner function. G composed with f is g of f of x. That means go to g, replace any variable you see with the other function f of x. F composed with g of x means go to f, replace any function you see with g of x. And we're going to do two things with compositions of functions. We're going to find them at numbers. We're going to evaluate compositions at numbers. And if you're evaluating it at a number, you expect your final answer to be a number. The other thing we'll do is evaluate compositions at in terms of x, in which case the function is a function of x. Let's look at number 4. Number 4.
So this is how you find a composition of two functions if there's a number here in the parentheses, not an x.
Now, if you want to find a h composed with f at x, you expect your final answer to be a function of x. A composition at a number, your final answer is a number. So f of x is 5x minus 1, and let's see, h of x is the negative of x plus 3.
Let me say in words what you're going to do right now. You start with the 3, plug it into the function beside it, the f. Then take that answer, plug it into h. How do we write all of that symbolically? Plug 3 into f and then take that answer and plug it in for h.
H composed with f of, I didn't see what the number was. 3. Okay. I'm going to write it using this composition notation. The letter that's written on the outside, that's written first, is the letter that's going to go on the outside. So we have an H on the outside, and on the inside, we have f of 3. There's the function f of x. We need to find f of 3. Ignore the h and everything else. Just focus on that f of 3. That says go to your function f, and wherever you see a variable, what are you going to plug in? 3. So you come up here. Here's my scratch work. 5 times 3 minus 1. What's that going to give me? 15 minus 1, I agree with 14. You still have the h sitting in front of there. F of 3 we found to be 14. Now what's this notation saying to do? Okay, you're going to go to h and plug in the 14. This is just repeated function notation. You plug the 3 into f. That gave me 14. You take the 14, you plug it into h. So you come up here. You have a negative. Replace the x with that purple 14 plus 3. What's that going to give me? Negative 14 plus 3 gives me negative 11.
So in words, plug 3 into the function beside it, f. Take that answer, plug it into the function beside it, h. And what's all of this? That's symbolically what this is saying. Plug 3 into f, you get 14. Plug 14 into h, you get negative 11. Right?
Well, you know something? I'm going to make up an example. I'm going to still use the same functions. Here they are. F of x is 5x minus 1. And h of x is
negative x plus 13.
This is not part of the problem.
No, plus 3. I said the wrong thing.
Oh, plus 3.
Plus 13.
There, plus 3.
What are you going to find?
Instead of h composed with f, I want us to find f composed with h. Suppose the f was first. Are we going to get the same thing? F composed with H. That says F is the outside function. That's what we're going to write first. F. The inside is H of 3.
So in words, how is this one different from the one he just did? Over here you took the 3, plugged it into F first.
Where are we going to plug the 3 here? Where are we going to plug the 3 there? Is the 3 going to be plugged into F? You plug the 3 into H. So you have a negative 0, no, not a negative 0, a negative 3 plus 3. What's that going to give us? 0. So H of 3 is just 0. Any questions on our logic there? We plugged 3 into H. That gave us 0. Now what's this notation saying to do? Go to F and plug in 0. So you're going to have a 5 times 0 minus 1, which gives me a final answer of. Okay. Operations are classified as commutative and non-commutative. Addition is commutative. A plus B always equals B plus A.
What about subtraction? Is subtraction commutative?
A minus B, does that always equal B minus A?
5 minus 3, 3 minus 5? No.
No. Okay, what about multiplication? Does A times B always equal B times A? Yes. But what about division? No. A divided by B doesn't usually equal B divided by A. So now we have this new 5th operation called composition. Fog and golf, whatever you want to call it.
It's fog and golf up here.
Here it's Hoff and...
That's one of the bad problems.
I don't know how you would say FOA.
I don't know why the first problem with this stuff, they can't use F and G. Why does it have to be F and H? Okay.
So here's the question. Is composition of functions commutative? If you reverse the order of those functions there, are you always going to get the same thing?
No.
Sometimes you will, but most of the times you won't. So make a note. Composition of functions is not commutative.
If you want to
That's
say
important.
something tomorrow, someone says, say something algebraic.
Composition of functions is not commutative.
I'm not sure they're actually going to use that in any of the problems.
No, but if it's a test question and they ask you to find F composed with G and you find G composed with F, do you think you got the right answer? Probably not. Composition of functions is not commutative. Remember, when we were looking at functions, we also looked at functions defined in terms of tables, trying to illustrate ordered pairs. I think the next one, here's a good one. Okay, let me write that. Number 5. They give us 2 functions, and they're defined in terms of tables. A while back, I remember states like Texas, people were trying to state legislatures were going through trying to decide, what do students need to be able to do when they finish their math classes, and realized some of these people know very little math. And so they were sitting around and they trying to decide, what do the students need to know? And someone said, tables. They got to be able to read tables. Well, and so all these algebra books around the nation, okay, we better put in some table problems. And I kid you not, that's when these table problems miraculously appeared in the best-selling algebra books. So there's
the best-selling algebra books.
They make way more
Stephen
money.
King does not sell a brand new algebra book costs $200-$300. There's no author selling a brand new book. Maybe first editions of
Gone with the Wind, some famous book. I don't know. What's a famous novel? I don't know where Gone with the Wind came from. I have to say I'm 59 and a half, and I've never seen that movie. So,
Has anyone ever seen it in here? Oh, you have? It's a
very
yeah.
long.
But wasn't it in color? I
The
think
one
it
that I
was.
watched was in color.
Okay, I think it was filmed in color. Maybe that was what was famous about it.
Film in black and white, and they not re-
oh, they colorized it.
Oh,
They
wow.
colorized it. Okay. But the point is that math textbook authors, that's huge money. That is big money. So,
Well, right up Fog 9.
okay, they want us to find Fog 9, F composed with G of 9. What letter's my outside function? F or G? Which one am I about to write first?
And you second.
Yeah, the one you write first is what you use second in case you haven't figured that out. I'm going to write it without the O. What function's going to go first? Am I going to write the letter F or the letter G first? F first. It's not tricky. It's the first one written. You write it first. And then G of 9, that's the inside function.
You might wonder, why do they use this little circle notation? It was just developed to not have to have all these parentheses here. But you write them with the parentheses anyway, right?
Yeah. Okay, so start on the inside. G of 9. Go to the function G. What number is 9 assigned to? Remember that number inside the parentheses, that's acting like an X. What number is 9 assigned to using the G's table?
Yeah.
9 is assigned to 7. I agree. And now we want F of 7. So we go to the F table. 7 is assigned to 11.
And so you just instead of trying to show your logic, what are you doing?
9 went to 7. 7 was assigned to 11.
So let me type in 11. There's another table here.
Well, that was hardly worth the time of writing out the table. I wasted all that time, the ink writing those tables. Let's
One
look
of these
at these.
tables. Look at what you're told to find. It doesn't say fog, does it? Find F of 5, or F composed with F. Do
F
we need
composed-
the G table? Is this one of those streets I drive past every day, but I never drive down? Yeah, they gave you that G, but you didn't need it. So you just write down the F table.
Okay, I'll write down the F table. Although I think they could just call it out in the time it takes me to write this table down. But don't worry.
Could y'all look at this and start with the 5.
Wait a minute. I'm switch over to my table.
Oh, right.
Switch over to my table.
Oh.
To my problem. I'm adding a new column here. I've changed up function F.
Huh?
I've added a new column.
But you're still doing...
I'm
I see
still
what
doing
you're
the same thing. I'm trying to make a point here.
Yeah,
tonight.
that's a very good idea.
We want F composed with F of 5. Add on this last column right there.
To make sure it's clear to you,
Which 5 you're using. We want F composed with F of 5. So you go to the F table. What number is 5 assigned to? We want F of 5. F of 5. What number does the F table assign 5 to? I see 2 different 5s in the table.
is he going to write, is it a 3 or a 7?
a 3. Remember that number is acting like x. You don't go to where the f of x is 5. You go to the x value of 5. It's assigned to 3. Now we want f of 3. 5 goes to 3. 3 goes to 6. If you have a 5 down there, that doesn't mean anything. That's not what the 5 you use. You use the 5, that's the x value. Any questions there?
I forgot what the answer was. 6? Okay. Okay. So those problems, you're looking at, there's a number in the parentheses. Do y'all see how problem 7 changes? It just says find fog x and golf x.
That means you're looking for...
By the way, if you're in Calculus 1 and studying the chain rule, and you're talking about fog and golf, and your teacher says, who did you have for algebra? You tell them it was T. Precella.
You tell him it's A. Precella. He's the one that I've just finally, after 30-something years, I've just accepted it. I say it, even though it raises my blood pressure every time I say it, or I hear Tony say it.
But
we used to be in
Tim,
separate rooms.
you know, at the end of the semester, if someone walks up to you and says, did y'all do composition of functions?
And they would say yes.
I think they would say, fog and golf. Did y'all do fog and golf? Oh, yeah, we did that. Okay. I think, okay. So I'm going to write down f of x is 9x minus 3. And g of x is 7 minus 4x. And what we are told to find is
F composed with a G in terms of x, and G composed
what did you
with
say
F
there?
in
Fog
terms of
x? Is that what we're finding first? Fog x?
F composed with G, and G composed with F.
What I'm hearing you say, Tim, is we're finding fog x first. Okay. So to find fog x, for all the people over there, I don't think anyone's over there. I know. Okay. Well, watch closely what we're going to do. To find f of g of x, that means plug g of x into f. Let's come over here and draw the arrows. We're plugging g of x into f. So in place of that purple x, I'm going to put all that black function g. 7 minus 4x. So that means plug g of x into f. So g of x, I'm plugging into f. Now what can I do to simplify that? Well, could we distribute the 9? And so we would have 63 minus, is that going to be 36x? And don't forget, we still have this minus 3 right here. You know, so anything we can combine, how about 63 minus 3, could I just write that as 60 minus 36x? Be careful, don't subtract 60 and 36, don't get a 24. Those aren't like terms. Sometimes students like to write it with the x first, so you're going to do that negative 36x plus 60. I'll leave it like that. It's 60 minus 36x. Is that how you would do it, Tim?
I leave it like that.
And now because, did I get it right?
Oh, yeah.
Okay. Now I'm going to go ahead and rewrite these just so we don't have all those arrows there. F of x is 9x minus 3. G of x is 7 minus 4x. But this time we're trying to find golf x. First teacher I ever heard. Do you remember who it was? Dr. Alston. When he said that time, I just laughed and laughed and laughed. I never heard anyone actually say fog or golf. And here this graduate teacher was saying it. So I decided, well, he can say it, I'll say it. Okay, in words, could y'all draw the arrows? How does this differ from 7? I'm going to plug f of x into g. So coming over here, I should have used a different color at this time. I'm plugging f of x into g. So in place of that black x here, I'm going to put 9x minus 3. So if I plug f into g, I have a black 7, a black minus 4. In place of that black x, I'm going to put the purple 9x minus 3. Be careful, don't subtract the black 7 and 3. Let me see what we'll have. I'll have to distribute the minus 4.
Remember your order of operations. You multiply before you subtract. So that's why you're distributing that minus 4 and not subtracting the 7 minus 4.
Said a minus 36x and a plus 12. Y'all caught up with me? We're plugging f into g. And once we combine the like terms, what are we going to have? A negative 36x plus 19. Or if you want to say 19 minus 36x. But really, this is better. I think you're less likely to want to subtract the negative 36 or combine the negative 36 and the 19. This 60 minus 36x.
Someone might be inclined to write 24x, which would not be right.
Just like the 7 minus 4x. What do you think? Someone might be inclined to write 3x, which isn't correct. But patch that in.
Negative 36x plus 19. Any questions, Steve? Just repeated function notation.
Let me see. Number 8 is number 8. F of x is 8x plus 1, and g of x is the square root of x. Oh, I think this might really show the process, the thought process better. First thing we're looking for is I think on 7, 8, 9, 10, 11, every one of them says find fog x, find golf x. Okay, so let's see. To find f composed with g of x, that means plug g of x into f. So I'm plugging g of x into f. So in place of that blue x, what am I going to put there? That red square root of x. Exactly. So I've replaced the blue x with the square root of x, and that's it. Notice the only thing under the square root symbol is the x. The plus 1 is not under that square root. So 8 square root of x plus 1. Oh, put your little mark, Tim.
Close that square. If Tony can say fog and golf, then I can put that little mark at 8 square root x plus 1. Is that what I wanted? No, the plus 1 is not under the square root. So I just use the right arrow, get out from under there before I type in the plus 1. Any questions there? Now we're going to go in the other direction.
And I'm going to recopy F and G just because I've already messed it up with the arrows. So go ahead and show what I'm writing. F of x is 8x plus 1. G of x is square root of x. Now, we are trying to find golf x. Hey, could y'all see in words what we're going to do? I'm going to plug what into what? Did y'all hear that? Perfect. You're plugging f of x into g. So how would I draw arrows to show I'm plugging f of x into g? Okay, that's going to be all of this in place of that red x. Okay, so in place of the red x, I'm putting the blue 8x plus 1. So we have the square root symbol. And now, in place of the red x, the blue 8x plus 1. Well, I've just noticed something. Maybe that's what bothers Tim. I'm circling a lot of stuff that's not the answer. Here's the answer to the first part. Here's the answer to the second part. I'm just putting the little star there to indicate that's the answer. Okay? So square root of 8x plus 1. So square root, and under the square root, 8x plus 1. Any questions? Are they going to see about this? Oh, okay. So number 9. Same instructions. Find f of g of x and g of f of x. The problem, let's see, f of x is the square root of 5x. And g of x is 1 over x. And the first thing was, okay, let me make sure I didn't miscopy it. F of x is square root of 5x. G of x is 1 over x. First thing we're looking for is fog x. Okay. That means plug what into what? It means plug g of x into f. Ooh, okay, so I'm going to plug a red 1 over x in place of that blue x. Ooh, okay. This could be a little messy. I have the square root. I have the blue 5. And then that's a times x, so it's going to be a times 1 over x. Let's see what I just did. Replace the blue x with the red 1 over x. And here there's actually some work to do to simplify. Not much, but a little bit of work I need to do. 5 times 1 over x, just multiply. Think of that as 5 over 1 times 1 over x. Is that just going to be a 5 over x? Yeah. And we're putting green stars by the answer, Tim, because there's so much circled stuff there, okay?
Now, I recall in the first homework assignment this semester, we were told, don't leave fractions under the square root, and we'd go through and rationalize. But sometimes, this is a much easier looking answer than the rationalized version, okay?
So if you remember rationalizing a denominator on that first assignment,
then you can, and they'll accept it, okay? But
rationalizing, I think, is only good if there's just numbers, no variables.
Yeah, I agree with that, okay?
Okay, so let's type that in.
Oh, you want me to type it in? Okay, here I am. Y'all tell me, what am I going to do first? What am I going to type first? Click that square root, and then it's a 5 over x.
Okay, so now we're going to do golf x. 20 short years, we're going to be finished here. And I just like to recopy the problem, f of x equal and g of x equal, because I know it's a mess with those arrows and stuff. G of f of x. That means plug f of x into g. So let me think. I'm plugging f of x into g. So that red x over here, all of that's going to get replaced with that blue square root of 5x. And it might look to you like I'm just writing the problem down and writing out the answer, and I sort of am. Okay? So I write the red 1 over, and in place of the red x, I put the blue square root of 5x. And that's what I will say is my answer with,
Once again, you could rationalize and get the square root of 5x all over 5x, but I think this looks a lot easier.
And I don't think they do that. They don't rationalize it on view and exam.
No, they don't.
There's really no reason why you would want to rationalize that. And type it in. Oops.
Let's see. Hold on. So, first thing, I'm going to use the fraction hot button. The only time I use just a little slash from the keyboard when typing a fraction is if it's one thing over one thing, one character over one character, basically. Here, I'm going to use the fraction hot button. On top, I have a 1. Click down on the bottom. That's when I have the square root of 5x.
And the way you would put the little mark to end it, that's like the blue box there.
That is.
Oh, wow.
Any questions there? Now, what did I say? Is composition of functions commutative? Will f composed with g always equal g composed with f? No, usually it doesn't. If they'd been asking us that question, we'd say no. Here on number 8, if they'd ask, is f composed with g equal to g composed with f? You'd say no, it usually isn't.
Now, why are you mentioning that, Tim?
Looking at number 10.
For
f of x equals 3x minus 6, and g of x equals 1/3 times the binomial x plus 6, find f composed with g of x and g composed with f of x. That's what we've been doing. But look, they have another question. Determine whether f composed with g of x is equal to g composed with f of x.
So there's one extra step on these two problems, 10 and 11.
You're going to have to look at the final answers and see, are they equal? Under most circumstances, what would the answer be?
No.
The very fact that they're asking this makes me think it must be an exception. Maybe they are equal in this case.
But let me write down the
Let's
problem.
see. Why would they be asking that otherwise? We've already said they're practically never equal. Only under a very rare situation would the composition be equal. Maybe this is one of those rare circumstances. Let's see.
So f of x is 3x minus 6, and g of x is 1/3 parentheses x plus 6. Okay. We're going to switch it over, Tim. Okay, so finding f of g of x, or f composed with g of x. That means plug g into f. What I'm doing with these arrows is actually, you're saying, oh, I don't do much here. You're right, but it's those arrows that's actually the work. I'm plugging G, all of that, into F. So in place of that blue X, I'm going to have I still have the minus 6, okay. In place of that blue X, I'm going to put a times 1/3 x plus 6.
Remember, you multiply from left to right. So this works out very nicely. Don't start trying to distribute a 3. You multiply from left to right. 3 times 1/3, what's about to happen?
3 over 1 times 1 over 3. It's just going to cancel, and we just have a
What are you going to distribute, a 1?
Mm-hmm. So, distributing a 1, it's just
X
plus 6. And we still have a minus 6. That was this blue minus 6 here. Oh, this simplifies nicely. What are we going to get at the end? Just the x. Okay. So, there. Oh, finally something easy to type in. X.
Okay, now let's find it in the other direction. G composed with F.
Okay, let me rewrite the problem just so I don't have too many arrows all over the place. Okay, so we're finding g of f of x, or golf x. That means plug f of x into g. So could y'all draw the arrows for what we're doing? We're plugging all of this in place of that red x. So I'm going to replace the red x with the blue 3x minus 6. So I'd have a red 1/3. In place of that red x, I'm putting 3x minus 6. How is this going to simplify?
Something happens nice with the 6's.
Yeah, negative 6 plus 6, so we lose the 6's. And what about 1/3 times 3? Up here we said 1/3 times 3, they canceled out. Do they still cancel out? Yeah, 1/3 times 3 over 1.
What are we left with here? Just 1x, so x.
So now,
this is one of those special cases where the composition in both directions reduce to the same thing, x.
it'll ask, does fog x equal golf x? And I'm going to say what for that?
Yes.
Yes. So did you type in the x?
No.
Do you have a really good memory? and you're going to do this assignment real soon. Remember for number 10, everyone's number 10, XX, yes. Right? Let's see about number 11. But if you're going to wait a few days to do it, well, you will have forgotten then.
Functions whose composition reduces for everything cancels out except for x in both directions are said to be inverse functions. And that's one of the assignments that's coming up very soon. We'll
After
have
zeros.
We have zeros and then inverses. So this is assignment 18. So and 2 assignments after this, we'll be looking at inverse functions. And those are functions whose compositions reduce to x in both directions. We'll discuss the significance of that when we get to that assignment.
The cube root of 6x plus 5. Oh, wait, this looks like the messiest one so far. And g of x is a 1/6 x to the third. Ooh, minus 5/6.
Find f composed with the g of x.
Plug what into what? Plug
Good.
g of f into g of x into f. Oh, wow. It's going to be messy. In place of this blue x, I'm going to put all of that red 1/6 x to the third minus 5/6. Okay? So in place, I'm going to draw the blue cube root. This point I'm going to make it big. In place of that blue x, I'm going to put all of this, but I still have that plus 5 right here. I want to go ahead and write that down. So I'm replacing the blue x with 1/6 x to the third minus 5/6. 1/6 x to the third minus 5/6.
Well, it looks to me like you're going to have to distribute that 6 over the difference there. Something nice is going to happen when you do that.
When I distribute that 6, am I going to have any fractions remaining?
No, the denominators of 6 are going to cancel.
Okay.
So all we have is a 1x cubed, which is just an x cubed. What are we going to have here?
6 times 5 over 6. 6 times 5 over 6. Will the 6's cancel here?
So we're going to have a minus 5 left. And what else do we have stuck on there? A plus 5. Well, I think something's about to disappear. What is it? The 5's, okay.
And then there's something else nice here.
The cube root and the cube.
What's going to happen to those? Those cancel out, okay? A cube root and a cube cancel. So what are we going to be left with here?
Just x. Any questions on our logic there?
Now see, that's messy manipulation. Cube root and a cube cancel out.
Everything cancels out except for the letter x.
If I was going to have to guess, and I don't, for the next one, g of f of x, I would guess it's going to be x also. Okay, but I don't have to punch in that x just so that they'll
feel more comfortable with your abilities.
Right, I don't know if I would go that far. Okay, now let me rewrite f of x equals cube root of 6x plus 5 and g of x is 1/6 x to the third minus 5/6. Oh, well, at least on the bright side, this is the last one. So,
There's still 2 cut point problems at the end of the assignment, though, but for the new material, this is it.
so let's see. I'm plugging what into what? I'm plugging. What? Plug f of x into g. Plug f, oh gosh, into g. Do y'all see why I'm saying oh gosh?
It's going to work out nicely.
It'll work out nicely, but at first glance it looks terrible. In place of that red X, I'm going to put all of this blue stuff. Let me do this. Okay, so in place of the red X, I'm going to put the cube root of 6x plus 5, and a lot of stuff is going to start canceling out now. What's the first thing to cancel out? The cube and the cube root. Okay? So those cancel. I'll mark those. Okay. And we have the time. I'm now just to make it look a little neater. I'm going to try to rewrite it. But I'm not going to try. I'm going to rewrite it without those marked out cube roots and cubes. And now,
What do we have to do with these the 1/6 in front of the parentheses?
distribute it.
Distributed, I agree.
So the 1/6 times 6, are those canceling out, leaving us just a 1?
So we have a 1x
Now,
plus,
here it's not, the 1/6 times 5 don't cancel out. What does that give us? Plus
5/6.
5/6.
And what have we still got stuck on there? A minus 5/6.
And 5/6 minus 5/6, that's gone. Leaving us just the x. And so does f compose with g of x equal g composed with f of x? Once again, yes. It happens very rarely. It happens so rarely, that's when these functions are called inverse functions. And 2 inverse functions, it's going to turn out, cancel each other out.
When performed consecutively.
Okay.
So,
Patching x and
x and yes. Any questions there?
so
We're going to do Chromebook testing 1 week from today. 1 week from today will be Chromebook testing, or if you just have a tablet that doesn't run the programming, that monitoring system, or if you just want to take it in here rather than take it at home, then we'll be doing that 1 week from today. But the next time,
I have to log back in.
yeah, let's see.
I just wanted to show y'all, we did make some slight changes on the due dates and while we're recording this.
Oh, let me stop it.
Okay.